Here's a figure. HJKM is a quadrilateral. Given D is the midpoint of MJ, I have given angle HJM is congruent to angle JMK. Prove HKM is a parallelogram. So that I've written in black the givens. I'm going to write in red what I get from that. I'm going to plan out what I'm going to do. Then I will write the formal proof. I have to write a proof for this. So if D is the midpoint of MJ, then by the definition of midpoint, MD and DJ are the same. And then I've got these vertical angles. They're the same. By the definition of vertical angles, they're the same. So now I've got angle, side, angle, angle, side, angle. And that's one way to prove that triangles are congruent. So now this triangle, JDH, and triangle MDK, those are congruent triangles. That will tell me that HJ is congruent to MK. Corresponding parts of congruent triangles are congruent. So I've got HJ and MK congruent. There's a theorem, I don't know what it's called in everyone's class. Sometimes they go by principles of a parallelogram or ways to prove a parallelogram, then they list them out in numbers. But the theorem is theorem number 49, geometry theorem number 49, states that if two sides of a quadrilateral are both congruent, equivalent in length, and parallel, then that quadrilateral is a parallelogram. And check this out. HJ and MK are cut by transversal MJ, and alternate interior angles are congruent. If alternate interior angles are congruent when a transversal cuts two parallel lines, then it's called the alternate interior angles theorem. Then it is then the lines are parallel. So by the alternate interior angles theorem, those angles being the same tells me that those are parallel. So now HJ and MK are both parallel and congruent. Therefore, HJMK, by theorem 49, is a parallelogram. So I'm going to put D, midpoint of MJ. That's a given. I'm going to put angle HJM congruent to angle JMK. Now, sometimes some course will make you say the measure of angle HJM is congruent to the measure of angle JMK. And then you have to use the definition of equivalent to say they're congruent. But who knows? It's enough to know that they're the same. That's a given. And so now, from there, I got that MD is the same. The measure of MD is the same as the measure of DJ. And again, sometimes they want you to draw more steps, and you have to say they're congruent. But anyway, that is definition of midpoint. I've got that. And then I know that angle HDJ, angle HDJ, and again, you might have to put the measure of angle HDJ is the same as the measure of angle MDK. It's vertical angles. Definition of vertical angles. Vertical angles. Well, is it the definition of vertical angles? Let me look it up. Definition in a proof show vertical angles are congruent. Let's see what it says here. To prove we can use the fact that when two lines are side to demonstrate given steps. Wait a minute. I want to see. Okay, how to write in a proof that vertical angles are congruent. To prove you would typically use the fact that vertical angles. Oh, the vertical angles theorem. Vertical angles are the same. So this is the, not definition of vertical angles, but the vertical angle theorem, that vertical angles are congruent. Vertical angles theorem. I don't have all these theorems in front of me, that's why I don't know. So now I know that HDJ and MDK are vertical angles, and now I know that triangle MDK is congruent to triangle JDH. And notice I named them, so I'm starting with the side that I know is the same. And that is angle, side, angle. And then I know that HJ is equivalent to or congruent to MK. And that is by corresponding parts of congruent triangles are congruent. And then I need those to be parallel, so I know that HJ is parallel to MK, and this is by the alternate interior angles theorem. The alternate interior angles theorem is true and the converse. If two lines are parallel, then alternate interior angles when they're cut by a transversal will be congruent, or the converse, when alternate interior angles between two lines cut by a transversal are congruent, then the lines are parallel. So HJ and MK are parallel. Well, since HJ and MK are parallel and are equivalent, are congruent, and HJ and MK are parallel, then now it's called Theorem 49. I don't know what it's called. In some classes, they go by the principles to prove or ways to prove that figures are parallelograms. This is Theorem 49. HJMK is a parallelogram. And that's by Theorem 49, which states that if opposite sides, one pair of opposite sides, is both congruent and parallel, then the quadrilateral is a parallelogram. So again, I don't know what it's called, principle number, whatever number it is, that says if opposite sides are congruent and parallel, then it's a parallelogram. So there it is. There's the proof that is needed for this situation.